Hello, this is Mr. Wakefield again, and we're now in section 3.2. Um, Going back to word problems again, we saw word problems as well back in section 1.5. In that section, the problems were a little bit smaller, but there's definitely a lot of similarities with this section, though, at the same time. In that section, we looked at problems where we just had to answer one question. This is 1.5 right here. Just one question, and we had formulas to help us with it and everything. And we had it, since we had one question, we attached that question to a variable, solved that variable after coming up with an equation, and so on. Now, in this section, the difference is that we are now going to have two questions. Okay, so the steps that you do for the word problem when you have two questions instead of one is basically the same, except for right here in steps 3 and 4. You still have to identify what you're trying to find, attach variables to it. I'll get into that. All right, but then when you get into step 3, if you're asked to find two things this time, you need to first of all, you need to have two variables, and I'll mention that when we do the step 2 portion of each problem. Okay, you'll need two variables, but then when we get to this step 3 here, because you're trying to find two things with two variables, you need to write a system of two equations now with those same two variables in it. Okay, unlike in 1.5 where you just needed one equation for the one variable, because you're now going to have two variables, you guys. And why we have two variables is because we're looking for two things here. We're going to have two questions. So each question is going to have a different variable attached to it. All right. And so those two variables will then be in a system that you need to find. Okay. You'll find the equations just the same way we did in 1.5, kind of the same way, but it's just you need to find two of them now. Okay. Now we have some formulas, as you see here, just like we did in 1.5. Different ones than we did in 1.5. These are different formulas, but we'll learn how to use each one of these. All right. The first one that we're going to, you know what, actually, let me read the problem first here, because we don't need the formula until we get to step 3. So let's read the problem first. It says you invest $20,000 in two accounts. That means $20,000 combined in the two accounts. And they pay 7% and 8% annual interest, respectively, okay? If the total interest earned for the year is $1,520, how much was invested at each rate? First of all, I want to remind you that what you invest is not the same as interest. We'll get into that right now, okay? Let me just give you a real simple example of what interest and investment, what all that means here. When we do interest here, we're going to be using this formula to help us. Again, this is when we do interest and investing things and stuff like that. All right. I mentioned that because there's going to be other problems that involve money as well. I don't want you to get those problems mixed up with these ones. So when you have investment and interest and all that, the principal is the amount of the investment. Okay, so I'm just going to make up a number here just to show you how the formula works. It's not the same numbers as in this problem. Let's say, for example, you invest $1,000 into a bank account, $1,000, and you have let's say it's a 8% interest rate. If you convert 8%, just like we did back in 1.5, if you convert that to a decimal by dividing by 100, 8 divided by 100, that would be 0.08. Okay, 8% is going to be 0.08. Okay, and the way to figure out the amount of interest that you earn over the course of a year, because this formula is just for 1 year, okay, is to actually multiply these two things together. Okay, so principal times rate is equal to interest. What is 1,000 multiplied by 0.08? If you put that in your calculator right now, that is going to be $80. Okay, and so I just wanted to make you familiar with how the formula works. Principal times rate is equal to interest. Back to the problem now. It says how much was invested at each rate. Each rate, there are two rates, right? That means we have two questions here. Okay, how much was invested at 7% and how much was invested at 8%. Okay, so let's write that down. Investment at 7%. Investment at 8%. And since we're trying to find two different things, I need to have two variables for that, one for each question. Okay, two questions here that we need to answer. I'll call it X and Y. You can call it any two letters you want as long as it's not the same letter. It's got to be two different letters. You could call it A and B if you want to, okay, for example. But I'll call it X and Y. All right, so here's what we're going to do. When we have two different investment accounts, and this is going to look very similar to the other problems that we do in this section. And that's what's good about these problems in this section is they're all going to have a similar format to it. And that'll make it easier because word problems a lot of times are tough because each one has a different format a lot of the time. In this section, you're going to find that the formats are very similar, not all different. So that's nice. Now, the way the format's going to work is that you're going to have 3 rows and 3 columns. 3 rows and 3 columns. Okay, the reason why we have 3 columns is what we're going to do is we're going to put the formula at the top. Since this is an interest problem, I'm going to put P times R equal to I at the top, where each of those 3 things has its own column. Okay, and you have to put it in this order or it's not going to work. Okay, now the 3 rows represent first of all, the first 2 rows represent the 2 investments that you're doing. Okay. And then the last row is actually what we call we'll call it the together row. You could call it the mixture row. It's where you look at the 2 investments together. And if you look at the problem, that's exactly what they do. They say that if you invest these 2 things together, you're investing a total of $20,000. And if you invest these 2 things together, your total interest for those 2 things together is $1,520. So that means that we need this together row at the bottom in order to use that information to help us here in this problem. But that's what these boxes are for. When we fill in these boxes, it's going to organize all of our information so that we can come up with those 2 equations that we need that I mentioned a few minutes ago when I said that we have to set up a system of equations. You always want to start out with the first column and then go across, second column, third column. Another thing is that here's the first box right here. The first box is going to be the principal at 7%. Do you know the principal at 7%? If you know what it's equal to, like for example, if you know the constant number that it's equal to, if for example, you knew that it was $2,000, then you would put $2,000 in here. If you knew it was $5,000, then you put $5,000 in here. We don't know what the principal is at 7% because remember, principal is the same thing as investment. Okay, when you don't know what the box is equal to, principal at 7%, but you actually have a variable for that particular thing. Remember, investment at 7% is the same thing as principal at 7%. Then you put the variable in there instead. Okay. Same thing here with the next box down. We just work our way down. We don't know what the principal is at 8%, but we have a variable for it, so use that. Okay, and don't make any additional variables either. That won't work. Okay, just stick with the variables that you have. All right, but because these 2 things were equal to X and Y, we put those in there. Finally, together, the total principal altogether, in other words, the total investment altogether, they actually tell us what that's equal to, don't they? That's $20,000 because it says that the total investment is $20,000. The next column is the rate, okay, and that's the percentages. So just like we did in 1.5, we convert those percentages to decimals by doing 7 divided by 100 and 8 divided by 100. Again, that's what you do when you're getting rid of the percent symbol because you can't put percent symbols inside of equations. All right, so we want to convert the percent to a decimal and thus get rid of the percent symbol. Now, this next thing is not going to happen on all of these problems, but I will say this. When you're looking at the bottom, the middle box on the bottom row right here, and I'm just talking about that one. All the other 8 boxes are different. But when you are looking at just this middle box on the bottom, if you don't know what it's equal to, and they don't tell us the rate for together, they just tell us the individual rates. If you also don't know a variable for that, and we've already used up our variables on these 2 things because they're investment, they're not rate, okay? So that you can't put a variable here either. If you don't know what this is equal to, and if you don't have a variable for it, then we're going to leave that blank, okay? Please don't try to put something in there if you don't know what it's equal to and if you don't have a variable for it either. All the other 8 boxes, you guys, should be filled in. You should be able to do that, okay, based on the information I give you. But that one sometimes isn't. Sometimes it will be filled in, I'll show you that, but sometimes, as in this case, it's not. In this last column, okay, first of all, again, if you don't know what something is equal to and you don't have a variable for it, and that's the case here with this as well, because this is the interest off of 7%. No, you do not put 1520 in there, because 1520 is what? 1520 is the total interest what? All together. So that would go here, right here. Okay? I'm going to put that in there. But the individual amounts of interest that each individual account earns, we don't know that. If you are in the last column, you guys, and again, I'm not talking about this box here, but instead in this last column, if you don't know what a box is equal to and you don't have a variable to put in there because the variables were already used up over here, then as a last option that you have, you are allowed to multiply across, because the formula says first column times second column is equal to the third column. So you are allowed to do this. 0.7 times x, write that in there. 0.8 times, 0.08 times y, you're allowed to multiply that in there. Because first times second column is equal to the third column. You're allowed to multiply across. I can't multiply across on the third column, on the third row, because I didn't know what that box was. But that's okay though, because you only multiply across, you guys, if you don't know what this is equal to and you don't have a variable for it either. But I already did know what that was equal to. Always try to figure out what the box is equal to first, or put a variable in there if it's one of your variables. If you can't do either one of those things and you're in the last column, then you multiply across if you're able to. Okay, so now what does all this accomplish now? We've got this nice box here with all this information. It's all organized. Okay, here's how it works. And this is going to work on all 8 problems in this section. That's what's really nice about it. Okay. You can add down on the first and the third column to create an equation. Not the second column. Don't ever do the second column, but just the first and the third. If I add down on the first column, I get this right here. That's a legitimate looking equation. Doesn't that look a lot like an equation from 3.1? Back when we were doing systems of equations in that section. All right. Same thing with this, except for it's got decimals in it, but that's okay. But we can add down on the third column as well, and that gives us another equation. So other than the decimals, which look a little bit odd, other than that, it looks just like a system of equations that we saw in the last section. All right. But decimals are okay. They're just they're coefficients, just like regular looking coefficients as well. So we're fine. Now that I have a system, that completes step 3. Step 3 is to find that system. Step 4 is to what? Step 4 is to solve the system of equations, if it's a system. And so we're going to do that right now. The way we do that is to either do substitution or elimination. Because we have decimals, I prefer substitution, but I'll leave it up to you. All right. So because I'm going to do substitution, I'm going to get either x or y by itself. Since they both have coefficient of 1, they're both about the same as far as difficulty, as far as getting it by itself. I'll go ahead and get the y by itself, and I do that by subtracting the x, just like normal. Subtract the x over so that the y term is by itself, and then you don't need to divide because the y is already completely by itself. There's nothing to divide out there. As you guys know from the last section, though, Since I got this first step of the substitution method from the first equation on top, I then plug that result over there into the other equation, this one right here. Let's try that. So I'm going to, since y is equal to 20,000 minus x, I'm going to plug in 20,000 minus x into the second equation and then solve that. Again, very similar to what we did in the last section. We then solve that resulting one variable equation. Be very careful since we have decimals this time. Okay, we need to distribute the 0.08x. 0.08 times 20,000, pardon me, is equal to 1,600 on your calculator. I then distribute the 0.08 times negative x, and that's going to be negative 0.08x. All right. And then after that, we're going to combine like terms. Again, be careful with those decimals. 0.07 minus 0.08 when we combine like terms is going to be negative 0.01 on your calculator. And so that makes that negative 0.01x. I then move over the 1,600. And I get negative 0.01x equal to negative 80. I then need to divide out. If I divide out right there by negative 0.01 to get the x by itself, what do I get? And I get x equal to 8,000. Okay. Y is equal to what? Well, after you figure out the first variable, you plug it back, and when you're doing the substitution method, you go back and you plug it into the equation that you got by itself at the end of step one. All right, and that'll allow you to solve for the other variable. Right there. Okay. 20,000 minus 8,000 is 12,000. Okay, we're almost there. We figured out what x and y were equal to. Back in 1.5, after we figured out what the variable was equal to, we then talked about how it was measured. Okay, most word problems have measurement in it, okay, such as dollars or ounces or feet. In this case, since x and y represent investment, that's money, and so it's either going to be dollars or cents. What is it in this problem? Well, since they use dollars in this problem instead of cents, it's going to be dollars. And so that means that the two answers that we got are $8,000 and $12,000. We're not quite done yet. There's one more little thing I got to do. But you got to remember to put the measurement on your two answers, okay? Because there's measurement in the problem, such as dollars, okay? Just like we talked about in section 1.5. If you want to review what exactly I mean by measurement, I talk about that in 1.5, okay? But measurement needs to be attached to each one of these answers here. You can't just say the number, okay? Now, the other thing you need to do when you actually find, we didn't do this in 1.5 because we were only looking for one thing. Here we're answering two questions this time instead of one. So that means you need to tell me which one is which here just to make it completely clear. Okay, so what you do is you go back to the original designation here of the variables, and it tells you what x and y mean. X was 8,000, but x was also the investment at 7%. Okay, so you don't need to write out that whole thing there. Just say that the 8,000 was the 7%. You can say that for short. You don't need to say $8,000 is the investment at 7%. You don't have to say all of that. You could just say $8,000 at 7%. I'll know what you mean. Okay, in the same way, 12,000, since that's Y, that is the investment at 8%. You could just say at 8% for short. Okay. The important thing is you're telling me which one was the $8,000 and which one was the $12,000. Don't just say $8,000, $12,000. Tell me which one is which. Okay, so when you're finding two things, don't forget your measurement, okay, and then tell me which one is which. This next problem is very similar to that, okay. It gives you the total investment, the total interest. It gives you a couple of different interest rates. All right, please try that. Again, the format is almost identical. Give that a try. Let's see how that comes out after you hit the play button again. Okay, number 2. So Karen invested at $11,000 in stocks and bonds, paying 5% and 8%. Okay, if the total interest earned for the year was $730, how much was invested in stocks and how much was invested in bonds? Okay. So again, they're asking for the 2 different investments here. Okay, they want to know the investment, same thing as principal in stocks and principal in bonds. That's the same thing as saying investment in stocks and investment in bonds. If you worded it that way, that's perfectly fine. Don't worry. Okay, so anyway, that's what X and Y are because those are the 2 questions. We do the same setup down here with the PRI on the top. Why did I do PRI? It's because this is an interest problem. They talk about investments and interest. And then I take the 2 things that are the 2 individual accounts. You can see here that the 5% is the stocks. Okay, the 5% is the stocks and the 8% is the bonds. And so that's the reason why I have stocks and bonds right here. The 2 different individual interest accounts go in the first 2 rows. The together row goes on the bottom. We needed the together row because they talk about the 2 investments together. Total principal is right here all together. Total interest is right here all together. And so that's why we need that last row right there on the bottom. Okay, so what's the first row going to be? I'm sorry, the first column. Do 1 column at a time here. The first column is going to be X, because that is the principal for stocks right there. Y is the principal for bonds. We don't know what those numbers are, but we have variables for them. So in that case, we put the variables there. Altogether, the total investment is $11,000, so I put that there. The rates are what? The rates are 0.05 and 0.08 because if I take 5% and 8%, I divide it by 100. Those are the 2 decimals that I get right there. Okay. Remember this last box down here in the middle is going to be blank unless they either tell you what that number is or they have a variable for it. Neither one of those things is true, and so we leave that blank. We then multiply across unless we know what these last boxes are. In the case of the last box there, we knew that that was $730 because that's the total interest for both accounts combined. But these other 2 boxes, we did not know what they were. We didn't know the number. We didn't know the variable. So we multiplied across, and that's where these 2 things came in. All right. And so that we now have the boxes filled in. Why did I end up with these 2 equations right here? Again, it's because I add down on the first column, pardon me. We add down on the first column and add down on the third column, okay, to get these 2 equations right here. So these are the 2 equations for your system, okay. Again, I'm going to solve it the same way here with the substitution method by getting either X or Y by itself here. A lot easier than getting these by itself. All right, remember you want to avoid fractions and decimals in your answer as you're going through the problem. That makes it a lot more difficult if you have fractions and decimals. So I got the Y by itself. I didn't have to divide by anything that would create a fraction or decimal, as I learned in 3.1. So then I plugged that result into the other equation. I solved that resulting equation. You can see I've got all that right here. Okay. And so X ended up being equal to 5,000. Okay. I then took the 5,000 and I then what? I then brought it back up here. Okay. And I plugged it back into this equation like normal, the equation at the end of step 1. That then allowed me to figure out what the other variable was. Okay. So now my answers are 5,000 and 6,000. Attach the measurement to each answer, which we'll need to do in all these problems in this section. Okay. Again, it's money, and so it's dollars due to the fact that they don't talk about cents in this problem. They talk about dollars. and then tell me which one is which. Since 5,000 was the X, and since X was the stocks, okay, you could also say 5,000 at 5% if you want, same thing, okay? But I said 5,000 in stocks. But the important thing is that you tell me the difference. You could either say one is stocks and one is bonds, or one is 5% and one is 8%. Okay, what's important is you tell me which one is which. So $5,000 and $6,000, but since 5,000 was associated with stocks over here, due to the fact that 5,000 is X and X is stocks, that's why I wrote stocks next to 5,000. $6,000 is bonds because 6,000 was the Y value, and it says here that the Y value was the bonds. Okay, so that is interest problems. All right, we have a couple other formulas that we need to take a look at right now. Let me get started with the second one here. The next one here is actually the one on the bottom. I'm going to do that first. I'm going to call it TPA for short here. Looking at this formula, T times P is equal to A. What this means here is that, let's say, for example, you have a certain liquid, anything that's liquefied, such as, say, a beverage that you're drinking, okay? And let's say that you're drinking a 20-ounce alcoholic beverage, all right? And let's say that that alcoholic beverage contains 10% alcohol. And so if you convert that to a decimal again, that would be 0.10. So the total amount in the entire beverage would go here. The total amount, the percentage of the subquantity, which in this case is alcohol, all right, is going to be 10%. So you convert that. If you multiply that together, it actually gives you the amount of alcohol. All right, so that would be 2 ounces. So 20 ounces in the entire beverage. Because it's 10% alcohol, that means that there's actually 2 ounces of alcohol in there. All right, the other 18 ounces that are in the beverage will be other things such as water and other things that are contained in that beverage. Okay, so let's say, for example, you wanted to know, let's say that this percentage was the percentage of wheat inside of that, like if it was a beer or something like that, and we know that beer has wheat and barley a lot of the time and stuff like that. Let's say that the beer was 10% wheat, okay? Then since this is the percentage is associated with wheat, this would be the amount of wheat. If this was the percentage of barley, then this would be the amount of barley. That's how it works. So the total amount of the entire thing goes over here. And then this thing over here is the amount based on the percentage, okay? So again, percent alcohol means the actual amount of alcohol. Percent of wheat means the actual amount of wheat. It just depends on which thing they're talking about there for the percentage. Okay, so let's use that to help us here in the next problem. In the next problem, we're going to be taking a look at two different things that have a percentage subquantity attached to it, like alcohol, for example. It won't be alcohol this time, but it's similar to that. Let's take a look. It says a candy company needs to mix a 30% fat content chocolate. In other words, what they're saying is they have chocolate, and 30% of this particular type of chocolate is fat. The other 70% is the other things you put inside of a chocolate piece of candy, for example. Okay, so fat is like the alcohol then. Whatever is attached to the percentage, that is that subquantity that goes in the middle of the formula there. Okay, so we're going to mix that type of chocolate with this type of chocolate that has less fat in it, 12% fat. And if we mix it together, it's going to give us 50 pounds of a brand new mixture that's going to end up being 20% fat. All right, so that's what we're going to be doing in the next couple of problems. Is we're going to be mixing together two different things that have a percentage subquantity. In this case, because fat is attached to the percentage, that the fat is the subquantity. Okay, so let's go ahead and find out what the question is now. How many pounds of each kind? So how many kinds are there? All right. You might be thinking, hey, there's 3 kinds here. No, actually, there is 3 kinds. You're right, but there's only 2 that they're asking for because they already tell us how many pounds there is in the mixture. There's 50, so they can't be talking about that, right? So they're talking about this here and this here. Those 2 things are the things that they want to know the pounds of. Be specific, you guys, to make sure that you know exactly what your variable is so that you can answer the question correctly. It's the pounds of the 30% fat chocolate and also the pounds of the 12% fat chocolate. That's what they're asking for here. Okay. Because it says that they want to know how many pounds of each kind there is. All right, so what we're going to do, again, it's kind of a very similar format as the previous 2 problems, even though it's not an interest problem this time. As I promised you, all these problems will be similar in the format with the boxes and everything. One of the differences, as you can imagine, is that it's a different formula this time because we're not doing interest. As I mentioned a moment ago, we're going to use TPA when we're doing, whenever we have 2 different things mixed together that have a percentage subquantity like fat or alcohol. That's when we use this formula in this order. Make sure it's in that order. And then just like with the interest problems, we're going to take the 2 things that are being mixed together. Even though we didn't mix the, I know we don't mix together interest accounts like we mix together chocolate, okay? But they were looked at together, so it is kind of like a mixture, okay? So similar things going on here where you take the 2 things that are being mixed, which is the 30% and the 12% fat content chocolate. I'll call it 30 and 12 for short here. And then the mixtures down here. You could call it the together row again if you want. I just call it the mixture row because we're literally mixing together the 30 and the 12% stuff, okay? But you can call it together. It doesn't matter. What's important is that the right information goes in the right place. But very similar to before where the mixture or together row always goes on the bottom, okay? So we're mixing these 2 things. They always go in the first 2 spots. Doesn't matter which one is which here. You can switch the 12 and the 30 as long as the mixture row is on the bottom. All right, now, again, let's start out with the first column and work our way over. Do we know the total amount of the entire thing for 30%? No, we don't, okay? But we do have a variable for it. I want to talk about that for a moment. You might be wondering, well, wait a second. When it says pounds right here, how do I know if that's the T or the A? That's a great question, okay? Remember, when they do, when fat is is attached to the percentage, 30% fat, 20% fat, 12% fat, just like 10% alcohol, okay, that means that this thing over here is the fat also. This is the percentage of fat, this is the amount of fat. All right, as we talked about, these 2 things are linked in that way. Okay, but when they say 30% fat, they're talking about the whole thing. If they had said pounds of fat without saying the percentage first in front of the word fat, that would have been different. Okay, pounds of fat would go here, but pounds of 30% fat, that goes in the T column. That goes in the T column. So when they say pounds of fat with the percentage in between, they are talking about this column here. It's the total amount of which 30% of it is fat and 12% of it is fat. So, just like the X, the Y is going to go right here. We don't know what the total amount of 30% fat chocolate is and 12% fat chocolate is, but we have a variable for it. Okay? That was the question, so we put the variables there. Do we know the total amount of pounds? And again, why do we know that the pounds go here? Okay, because that's the amount of remember, that's the total amount of the whole thing, and that it's measured in pounds. Okay, the 30% fat, the 30% fat, the 12% fat, and then the mixture, which by the way is the 20% fat. They tell us that it's mixing together to equal that. Okay, that is going to go in this first column. Okay, but we know that it's pounds because pounds is how the total amount of chocolate and fat is measured. Okay, but again, you don't put it over here. Because what does it say here? It says, in other words, you don't put these are both going to be pounds here, first and third column. But the reason why I want to put the 50 here instead of putting it over there, we know 50 is the mixture. But again, it's because it says 50 pounds of 20% fat. It does not say 50 pounds of fat. If it had said 50 pounds of fat, then like I said a minute ago, that would put it in the third column over here. But because it's 50 pounds of 20% fat, it goes into the first column. Okay. The percentages. 30% converts to this. 12% converts to this. And this time we are going to fill this in. Why? It's because unlike in the first two problems, they actually tell us the percent in the mixture. The percent in the mixture is 20%, so we put it in there. And what do we do for the last column? If we don't know what the amount of fat is, remember this is the amount of fat here in each one of these three boxes. We do not know the amount of fat, okay, for any of these three things. We already used up our variables on something else. And so as a last option, like I said before, we multiply across in order to fill in those boxes. 50 times 0.20 in your calculator is equal to 10. Okay. So we filled in the boxes. Just like in the first two problems, it works exactly the same way here as long as you set it up the way I showed you. Okay, you add down on the first and third column, but not the second one, and it gives you two legitimate equations that you can then use to solve. And then we solve it the same way. You can do the substitution method if you like. I'll get the y by itself here, and I'll plug it into the other equation, like always with the substitution method. Okay, and then we go from there. All right? Let me go ahead and write that down. Okay, so this is going to be y equal to 50 minus x. That gets plugged in. There it is right there. I distribute. I combine like terms. I then move over the 6 over with the 10. Divide out the 0.18. We're going to see something unusual here. In your calculator, if you put that in there, it's not going to come out as a nice simple little answer. It's going to come out as it should say on your calculator 22.22222 and so on. Okay, normally I won't give you answers like that. Sometimes I do. Usually when I do, I'll tell you to round it off. Okay, I apologize I didn't do that here. In fact, let me go ahead and make a note of that. Okay, don't ever round off though unless you're told to. So let me make a note of that so that there's no confusion with that rule. In this case, we're going to round off answers to the nearest tenth, which is 1 decimal place. Okay, so if you take 22.2222 on your calculator and you round it off to 1 decimal place, that is going to be 22.2. Okay. And I use that squiggly looking equal sign because that's what you do when you round off. If you forget to do the squiggly equal sign, don't worry about it. You can just use a regular equal sign as well. But that's what's normally done. Then we figure out the other variable like always. Plug that in to this equation up here. 50 minus 22.2 right here. And put that in your calculator and you get 27.8. And as always, just like in the first two problems, you take those two answers, 22.2, 27.8. First of all, tell me how they're measured. Okay. You can see over here when we designated this, and this is why it's so important to be specific here. Okay, don't just say X is 30% and Y is 12%. Be more specific than that so you know that it's pounds. You know exactly what you're looking for with detail here. Okay, so that when you write out your answer, there won't be any confusion. We know that X and Y are in pounds. Okay. And then you need to just tell me which one's which. Okay, so for 22.2, that was X, and since X was the 30% stuff, you don't have to say anything else. Okay, you don't have to say 30% fat chocolate, okay? Just say 30%, and I'll know what you mean. For the 27.8, since that was the Y, and since Y is linked to 12%, then that means that the 27.8 pounds is going to be the 12% stuff. And there you go. All right? So that's what you do when you have two different things mixed together that have a percentage subquantity. You'll see in the next problem here, which I'm going to ask you to try in a moment, that it does the same thing. It's going to take an alloy, which is a type of metal, and as you probably know, you can liquefy metal and mix it together with other liquefied metal. So the alloys are going to be liquefied. They're going to be mixed together here. To obtain 32 ounces down here. But let me read the whole sentence, though. The jeweler is going to mix an alloy that has 16% gold in it. So that's your subquantity, just like the fat and the alcohol. And then he's going to mix it with the alloy that has 28% gold in it. And that mixture is going to obtain 32 total ounces of a brand new alloy metal that now has 25% gold in it. Okay, so very similar to this, with the three different percentages. Okay, so go ahead and please try that, and then we'll see how you did after you hit the play button again. Okay, so again here in number 4, we're talking about, it says how many ounces of each of the original alloy metals must be used, and so they want to know, not the pounds this time, but the ounces. And so the ounces for each one, and it says original alloys. Those are the 16 and 28% gold alloys. Sorry, I need to zoom out there a little bit more. There we go. And the 16% and the 28% gold alloys, because those are the original alloys before they mixed them together to create this brand new one that's 25. All right. So that's what we're looking for. Again, a very similar to format here. TPA, because we're mixing together two different things that have a percentage subquantity. All right. The first column, we're going to look very familiar to what we've been doing. The X and the Y go here for the same reasons as before. All right. Because the 32 ounces is for the alloy with the 25% gold. It did not say, you guys, like I was talking about with the fat in the last problem, it does not say 32 ounces of gold. It says 32 ounces of the alloy that has 25% gold. So again, because it's 32 ounces of the 25% gold instead of it being 32 ounces of gold, that's why the 32 goes here and not over in the A column somewhere. Okay. The percentages are what? They are 16, 28, and 25. Convert those by dividing them by 100 in your calculator. And then the last column, we don't know what the amount of gold is. Remember, since this is percent of gold right here, this is the amount of gold right here. So we don't know they don't tell us the amount of gold for any of these three things, any of these three rows. We already used up our variables on something else over there. And so the only choice we have is to multiply across on all three rows. That's why it's so nice to have this formula here that allows us to multiply first column times second column equal to third column. So I did that, and it gives you this column right here. It then creates these two brand new equations here. Okay. And then we what? Then we solve that system, pardon me. I do it in the same normal way. I get the y by itself. You could have done the x as well because it's just as easy. But then you plug it back into the other equation. We solve that. There is the solution of that equation, x equal to 8. Okay, let me move that over. I plug it back into the first equation here at the end of step 1 to get the y there. All right? And so now that I've got 8 and 24, all right, what do I got here? That means that that's going to be 8 ounces and 24 ounces because we know that the x and y was measured in ounces from the beginning of the problem. We mentioned that. And then here, you can just say 16% and 28%. You don't have to say gold there. Well, again, what's important is that you tell me which one is which. So the 8 ounces is the 16 because, as we found out way back here at the beginning of the problem, since the 8 is the x and since the x is the 16%, that means the 8 ounces goes with 16%. Likewise, 24 ounces goes with the 28% because that's the y variable. All right, so that is how to do a problem where you're mixing together two different things that have a percentage subquantity, whether it's gold, fat, alcohol, whatever it may be. Okay. In number 5, as we move on, these last 4 problems are all going to be the same formula. They'll just be used a little bit differently in the last 2 problems, that's all. This last formula, it says that if you're mixing together things but you're dealing with money, let me be a little bit more specific about that. If you're mixing together 2 different things that have a cost per attached to it, let me say that again. In fact, let me show you an example. See here, they're mixing together 2 different things in this problem, cashews and peanuts. Mix cashews with peanuts. Notice that each of those 2 items have a cost per attached to it. Cost per pound. Cost per pound. It doesn't always have to be pounds. It could be cost per ounce, cost per inch, cost per mile, cost per whatever. Okay? But if the 2 things have a cost per attached to them that you're mixing together, then you're going to want to use this formula right here on the first page. I'm going to call that A times, you can either call this C or V here. Okay. Cost and value basically are the same thing here. Amount times value is equal to total value. All right. Cost and value, again, the same thing. You could call it ACTC. It's the same thing. But let me explain how that works. Let's say that going back to the problem I just mentioned with the cashews, let's say you buy 5 pounds of cashews. Okay? So you're going to buy 5 pounds of cashews. It says here on that problem that they cost $6 a pound. 5 times 6 is 30, but let's explain what these numbers mean. Okay? Whenever your problem has cost per pound in it, that always goes in the middle. Okay? Cost per pound. 1 pound. If it was cost per ounce, then the cost per 1 ounce would go in the middle. I'm not talking about the total cost of all the ounces. I'm talking about the cost per 1 pound, cost per 1 ounce. In this problem, it is $6 for 1 single pound. So that's why it goes in the middle. Okay. The total cost of all of the pounds, okay, would go here. If you were using ounces instead of pounds, then the total cost of all the ounces would go here, for example. And then the actual amount of pounds or ounces would go here. Okay? So that's why 5 times 6 is equal to 30. Let's say, for example, I was buying peanuts and I wanted to buy 10 pounds of peanuts. Okay, let me just give you one more example here. The peanuts cost $2 a pound. $2 per 1 pound, so I put the 2 in the middle because it's per a single pound. Okay, if I buy 10 pounds of that, you put the 10 there. Never put the money here on the A part. Okay, that's the actual amount of the pounds or ounces that you're getting. Okay, whatever the item is. You might be wondering, how do I know if it's pounds or ounces? Okay, it all depends on how it's worded. If it's per pound, then it's pounds in the A part. If it's the amount of ounces, then the A is the amount of ounces. Okay, so cost per pound is the amount of pounds in the first spot. Cost per ounce, if it was per ounce, then you would put the amount of ounces here. Okay, and we'll see other types of things as well coming up, and we'll be careful about going over that. So 10 pounds of peanuts at $2 per pound is going to be a total of $20 total cost, total value of all of those peanuts all together. Okay, so if we're mixing together two different things that have a cost per pound attached to them, or cost per whatever attached to them, then it's going to be a very similar setup to the first four problems, just a different formula mainly. Okay. A grocer needs to mix cashews worth $6 a pound with peanuts worth $2 a pound to obtain 10 pounds of a mixture worth $3 a pound. How many pounds of each kind of nut, in other words, how many pounds of the cashews and how many pounds of the peanuts must be used? Again, they're asking for two different things here because they're asking for the amount of the cashews and the amount of the peanuts. But be specific here, okay? Notice it says, and I said that wrong just a moment ago because I got a little bit careless there. I apologize as far as how I said it. Okay, you probably knew what I meant, but in math you want to be really exact. Okay, we're not looking for the amount of cashews and the amount of peanuts. We're looking for the amount of pounds of cashews and the amount of pounds of peanuts, and that makes a big difference. There's a difference between going down to the store and buying 6 single individual cashews versus buying 6 pounds of cashews, right? All right, so that's why we want to be really specific there. And it says how many pounds. Okay, it doesn't say how many cashews. It says how many pounds of cashews and how many pounds of peanuts. All right, anyway. Similar setup. Notice that our formula, once again, is 3 parts, so we're going to set that up the same way as usual, okay, where you have it go right across the top of the boxes here. It is A times V equal to TV. Again, when do we use that formula? We use it when we have two different things with a cost per attached to it. Cost per pound in this case. All right? And the cost per pound always goes in the middle. All right, per 1 pound. The two things that you're mixing, once again, will go into the first 2 rows, just like it was in the last couple problems. And then the mixture row, again, is on the bottom as always. And so then the first column, like once again, we start out with that. What is the amount of pounds? Remember, if it's a cost per pound problem, the first column is always the amount of pounds. Do we know those things? We don't know the first 2 things here, but we have a variable for them. Pounds of cashews. Pounds of cashews. The X then would go here. Same thing here with the Y. Do we know the amount of pounds of the mixture? We sure do. It says that when we mix it together, we're going to obtain 10 pounds of a mixture. So that means that the 10 goes here. Okay. Do we know the cost per pound of each of these 3 things? Yes, we do. $6 per pound, $2 per pound for the peanuts. It says it right there in the problem. And then it says that when you do the mixture is going to be worth what? $3 a pound. So the cost per pound, or the value per pound, goes in the middle. We do not know the total value of any of these 3 things. We know the cost per pound, which is the middle thing, but we don't know anything else about cost. And so this last column, we don't know nothing. Okay, but we can multiply across to fill that in. Like that. And good news, just like in the first 4 problems, we can add down on the first column and the third column. And no decimals this time. That makes it even easier. I'm going to go ahead and just to stick to my my normal theme here, I'm going to do the substitution method again, although doing the elimination method is not that hard at all here. I'm going to be a little bit different here, though, and solve for x to start out, just to be different. You can solve for either x or y there just as easily. Okay, but since I got that from the first equation, again, I put it into the second one. Like that. Okay, and then I solve that equation like always. So I'm going to distribute. I then need to combine like terms after that, right? Okay. So I get 60 minus 4y is equal to 30. I then subtract the 60 over with the 30. I get this right here. Now that I got a single variable term on one side and a single constant term on the other, I divide out. 30 divided by 4 in your calculator. I know normally when we get a fraction answer, we put it in lowest terms. I'd like you to give the decimal answer though here this time, because it's just easier to say a decimal answer here. If you were to put this in lowest terms, and it would be 15 over 2. But you don't normally walk up to somebody and say, I'm going to buy 15 halves pounds of peanuts, right? You normally would say, oh, I'm going to buy 7.5 pounds of peanuts or 7.5 pounds of peanuts, same thing. Okay, that is a little bit more realistic, right? And so that's why I put it in decimal form right there. I will tell you if I want you to put it in decimal form, though, just so that there's no confusion. Normally, as you know in previous problems, normally in most of the problems, if you do it in these word problems, that is, when you divided, it usually divided evenly. And so when you put it in lowest terms, it just ended up being a whole number, okay? But when it's not, you can do the thing where you just take the fraction and put it in the lowest terms. That's okay. If I wanted it as a decimal on, say, a test question, okay, I would tell you. The homework, it may not be that specific, but again, the test question, which is most important, I would tell you that so that you would not be left wondering what to do, okay? I then plug in the 7.5 into that equation that we normally plug it into, figure out x, and I've got 2.5. So my two answers are 7.5 and 2.5 what? Again, since x and y were measured in pounds, I put that there, and then tell me which one is which here. Again, you don't need a lot of specifics on that. The 2.5 pounds was the x, and since the x was the cashews, that means that just write down cashews next to 2.5 pounds so that I'll know what it was. Okay, and then the 7.5 pounds, that was the peanuts, right? Because that was the y coordinate. Like that. All right. And so that is number 5. Number 6 is very similar. But before I ask you to do number 6, though, I'm going to ask you to do 7 and 8 because they're very similar. They're not completely identical to what we're doing now, but they are so close that we're just going to do those right here. Okay, so number 6, you can see there that it's basically the same kind of problem except for they've got granola and raisins instead of cashews and peanuts. Very, very similar problem, though. I'll ask you to try that in just a moment. In 7 and 8, though, similar thing going on there. The only difference is that you're not actually physically mixing together things. You're not physically mixing the peanuts and cashews. Let me show you what I mean here. It says in a new development, okay, in other words, they're building a bunch of new residences here. 50 1- and 2-bedroom condominiums were sold. And so there's a total of 50 residences altogether. Some of them are 1-bed condos and some are 2-bed condos. Each of the 1-bed condos costs $120,000. In other words, that's 120 with 3 zeros after it. I just wrote the word thousand instead. Okay, and each 2-bed condo was $150,000. If the sales totaled $50,000, which again is just this number with 3 zeros after it, how many of each type of unit was sold? Okay, so let's take a look. Notice again here that, actually let me write down the question here first. It says how many of each type of unit. So how many different types of units do they have? they have a 1-bed condo and a 2-bed condo, right? So the number of 1-bed condos and the number of 2-bed condos. They want to know how many of each. Okay. Again, similar setup here. And then I'll explain how this is similar to the last couple of problems. Okay. 3 columns. 3 rows. Same formula. Here's why it's the same formula. Okay. Notice that each one of these two things has a cost per attached to it. The 1-bed condos are $120,000 per condo. The 2-bed condos are $150,000 per condo. Okay, so it's cost per condo, just like the previous problem that we did was cost per pound. Okay, the only difference is that we're not physically mixing these together like we would mixing together cashews and peanuts inside of a single, let's say, glass jar where you put a bunch of nuts in there. Okay, but these are being still mixed together in a sense because they're putting all of these different condos They're putting them all in this one development here. Okay, this one place where they're building all of these new residences. So in a sense, they are being mixed together in that they're all being put into this one place. So that's why it is just like the last problem. You've got two different things with a cost per attached to it, cost per condo, and they're being mixed together. What are the things being mixed together? The 1-bed condos and the 2-bed condos, just like the peanuts and cashews were being mixed together. And then you always put the mixture on the bottom row. First column, what do? X and Y, same reason as before. We don't know how many, again, since this is cost per condo right here, cost per condo in the middle, just like cost per pound. That means that this is the amount of condos and this is the total cost of all of those condos over here. Excuse me. But because this is cost per condo, the amount of condos always goes over here. Let me write that down. Okay, so the amount of 1-bed condos is X, as you can see here. The amount of 2-bed condos is Y, as you can see here. And so what's the total amount of condos altogether in the mixture? Isn't it 50? Okay. Because there's 50 total condos, right? What is the cost per condo? Now, since don't normally do this, you guys, but we can do it here in this problem. Because all the dollar amounts are measured in thousands, you can shorten it just to make it a little bit easier to write down these numbers. Instead of saying 120,000 and 150,000, you could say just those numbers, since all three of the dollar amounts are measured in that same way, with the thousand behind it, the word thousand behind it. Again, don't normally do that, okay, but it can be done in this problem. This one right here is one of those problems where it's blank because they do not tell us the cost per condo of all of the condos in the entire development. And I know that because in order to be able to fill this in, it would have to work for every single condo in the entire development. Okay. Some of the condos cost 120, some of them cost 150, so there's not one single dollar amount here that you could put here. Okay, so they don't tell you the amount of the cost of the condo for the mixture because some of them they're different. Some of them are 120 and some are 150. Okay, we don't have a variable for that either, so in that case we leave that middle box on the bottom blank. We don't know what these two things are right here, the total value of all the condos. In other words, we don't know the total value of all the 1-bed condos. We don't know the total value of all the 2-bed condos. But we do know the total value of all the condos mixed together. Okay, it's 50,000. Right there. Total value of the entire thing all mixed together, because it says the sales total. That means for the whole thing, right? For all the condos. And so that's for the mixture. Since I don't know these first two boxes, though, I multiply across like that, just like I've been doing. And not a surprise here, you add down on the first and third column, and it gives you, once again, two legitimate equations that will get you to the answer here. Let's go ahead and find out what that answer is. I'll get the y by itself here. Again, you could do this elimination method here as well. It's not too bad since it's the since there's no decimals, but because the numbers are kind of big, I'll go with substitution here. Plus, I like substitution, but that's just me. You have the choice in these word problems, you guys. You could do either substitution or elimination, either one of those methods you found in the previous section, 3.1. Anyway, let's solve this here by plugging that in. I then do my normal thing. I distribute. Let me finish that. I then combine like terms. I then move over the 7,500 so that I can then divide out. Final answer there for the X part anyway is 15. I then go back and plug it back into that equation from the first step, like always, and I figure out what the other variable is. 50 minus 15 is 35. So my two numbers are 15 and 35. 15 and 35 what? Okay. How are these things measured? Okay, they are measured as, the 15 was what? It was the number of one-bed condos, right? That's how it's measured. There's no dollars or ounces or pounds this time. The whole thing is just condos. All right, and when you put one bed in there as opposed to two bed down here, that tells me the difference. So they're measured in the number of condos. So the word condos is similar to the word pounds or the dollar sign. That's how it's measured. And then the one bed and the two bed part tell me which one is which. The 15 is the one bed and the 35 is the two bed. Okay, and so that gives you the whole thing right there. Let me zoom out. That gives you the whole thing right there, okay, telling me how it's measured and telling me which one is which, like we talked about. Okay, so that is what happens when you have things that aren't physically mixed together, but they're still looked at together. Same thing happens down here in the last problem. See how they talk about 100 people attend a fundraiser. Okay, some of them are members and some of them are non-members. The tickets for this event are different based on members and non-members, but see how it's cost per ticket for each of the members and the non-members? So the members and the non-members, they're like the peanuts and cashews again. They each have a cost per attached to them, but you're mixing the members and non-members together in the sense that they are all going to this one fundraiser. Just like all of the condos went into this one place where they're all built. And so you can treat it once again like the peanut cashew setup, okay, with the AVTV setup. Okay, so please try that, and also please try number 6 as well. So number 6 and number 8, give that a try, and then after you hit the play button, we'll finish up this section. Okay, so let's take a look at number 6 here first. Again, the raisins and granola, very similar to the cashews and peanuts in number 5. So we're looking for the pounds of raisins and the pounds of granola. Filling in the boxes, you see a very similar setup. We have 10 pounds total of the mixture. Excuse me. And but X and Y is the amount. Again, what do we mean by amount? Since it's cost per pound in the middle, due to the fact that it mentions cost per pound here in the problem, that must mean that this is the amount of pounds. And so amount of pounds is X and Y, and not a surprise that that would go here. In the middle there, we put the cost per. Remember, the cost per pound always goes in the middle. All right, and so I did that. The total cost or total value of all of the pounds of the raisins, granola, and mixture are going to be found by multiplying across, because for the same reasons as before, the only way to figure that out in this case is to multiply across. As you know, that's not always the case, but it is here in this problem, where you have to multiply across on all three of those rows. That creates the same situation where the first column and the third column gives you the two equations that you need. Okay. And then we solve that system. So I did my normal thing here, got y by itself. I plugged it into the other equation, solved it. Coming on down, I got x is equal to 6 down here at the bottom. Okay, plug it into that equation from the first step, and we end up with two answers, 6 and 4. Okay, measured in pounds, because at the beginning of the problem they tell us that x and y is measured in pounds. Okay, and we know that the 6 was the raisins and the 4 was the granola. Okay, due to the fact that the variables told us which one was which there, just like before. And so that, you guys, is number 6. Okay, in number 8, let's go ahead and jump down to that here. There were 180 people at a fundraiser. Okay, the members paid $4.50 a ticket. Non-members paid $8.25 per ticket. Okay, so we got that cost per ticket set up there. If the total receipts amounted to $1222.50, okay, in other words, total sales, same thing. So it's similar to the condo problem, total sales. How many members and how many members attended? So number of non-members and number of members tickets and number of non-members tickets. You don't have to say the word tickets in there. It's just that that's one and the same. However many members attended is the number of tickets that you had for members, and however many non-members attended is the number of tickets for non-members. So it's one and the same, okay, whether you put the word tickets in there or not. But it helps us understand, because since we have cost per ticket in the middle here, since they gave us cost per ticket in the problem, we know that cost per ticket means that this is the number of tickets. And so putting tickets into here just confirms, you guys, that these first two boxes are X and Y. Because A is the number of tickets for the members. The second box is the number of tickets for the non-members. All right, so we know for sure now that that's X and Y. The total number of tickets sold altogether was 180, because 180 people attended. The cost per ticket, as you can see here, again, this just like the condo problem, for the same reason, this box is empty. We can multiply across to fill in those first two boxes in the last column. Okay, and there's no other way to fill those two boxes in. However, we do know this amount without having to even try to multiply across. Okay, $1222.50, the total sales, the total cost. And I notice it says here ACTC. All right, again, that's the same thing as AVTV. We can even change that if that helps avoid any confusion. All right, there we go. So that leads to our same normal thing here, where we take the first and third column, create two equations, and then we solve those equations. Be careful here, because you have decimals. Okay, so I go through that normal solving process here. Get my 70 number right there, plug it in, get my other number, and so the answers are 70 and 110. Okay, Officially 70 and 110 is measured as tickets, but you don't. If you say 70 members as opposed to saying 70 tickets for members, that's really the same thing. Okay, like I said, the number of members and the number of tickets is exactly the same thing, and so you don't need to be as excuse me, I have to say that correctly. You don't need to be as specific in this problem as you are in some other problems because it does mean the same thing. So 70 members, 110 non-members, same thing as saying 70 tickets, 110 tickets for members and non-members. You do need to say members and non-members though, so that there's no confusion on which one is which. Okay. But we already know these are tickets because, again, it's simultaneous. It's the same thing as saying members and non-members. Okay, so that is the conclusion of section 3.2. I know there's a lot of stuff going on there, but I hope that the fact that the 8 problems have such a great similarity to them will certainly help you put all this together and understand it, okay, as you move on into your homework and eventually study it for the exam and all that. But, of course, let me know if you have any questions, okay? You have a good day, and you take care, and we'll see you back for section 3.3.